I'll introduce you if you like, and you can come up as I'll just say a little bit of. Good afternoon. I'm delighted to welcome Dr. Alfred Spector as the inaugural speaker in the 2008, the inaugural lecture in the spring 2008 View from the Top series. 2009. Darn. It says up there. Good. Okay. The real entertainment is to come. But let me just spend you a few minutes telling you a little bit about Dr. Spector. And the forum gives the college community a chance to hear from the best of today's business leaders and technology visionaries. And we're very glad to have Dr. Spector here today. Before I continue, I'd like to thank the good folks in Theta Tau, and here is the co-ed professional engineering fraternity for co-sponsoring today's event, along with the Berkeley Engineering Fund. I'd also like you to mark your calendars for the next View from the Top lecture, which is on March 6th, Friday, also at noon. It's Richard Karras, the CTO of Lucasfilm. But now, let me introduce Alfred Spector, who's the VP of Research and Special Initiatives at Google. Alfred joined Google in November 2007 and is responsible for research across Google, as well as a growing collection of special initiatives. That's the second part of his title, which are typically projects with a high strategic value to the company, but a bit outside the mainstream of current products. Previously, Alfred was VP of Strategy and Technology for IBM's software business, and prior to that, he was VP of Services and Software Research across IBM. He was also the founder and CEO of TransArc Corporation, a pioneer in distributed transaction processing and wide area file systems. And even before that, he was an associate professor of computer science at Carnegie Mellon, specializing in highly reliable, highly scalable distributed computing. Alfred received his PhD in computer science from Stanford and his AB in applied mathematics from Harvard. He's a member of the NAE, a fellow of the IEEE and the ACM. And he's the recipient of the 2001 IEEE Computer Society's Tsutomu Kanai Award for work in scalable architectures and distributed systems. Alfred is here to talk about Google's approach to innovation. From cloud-oriented computing to software architecture, technology is an important catalyst in Google's ability to rapidly generate ideas and turn them into valuable products, which I'm sure each of you uses every single day. So Google's power to innovate also relies on an organizational culture of employee empowerment. At Google, technology and organization converge through the internal use of web-centric technologies that promote optimal communication, measurement, and decision-making. Now, please join me in giving a warm welcome to Alfred to tell us more about innovation at Google.
Thank you very much. What a great turnout. Thank you. It's good to be your inaugural speaker of 9. Wouldn't it be great if we could get a year back? Have you figured out how to do that? Because if you do, let me know. I, for one, would like that. My 9-year-olds would not like that. They want it to be later, but I would like a year back. So I will tell you about some of these things here. I will harken back to the mission for a moment of Google, which you probably heard many times, but it's extremely important. I'll talk about why and how technology is a force for innovation at Google. I will discuss the empirical culture of Google, which is really rather different than has previously existed through at least most of my career in computer science. And it's a really big change, I think, in the field. Talk a little more about some other aspects of the culture, and then move into talking a little bit more about research at Google, which is perhaps my primary responsibility. So to get started, because I do want to go reasonably quickly through some of this material which you've heard before, our mission is to organize the world's information and make it universally accessible and useful. So it's really a terrific mission. I mean, it's an incredibly good goal to go do that. There's an enormous amount of benefit to the world for doing it. And we like that. That's why so many people have gone to Google, because they like that goal. But in addition, so many computer science problems are covered by that goal. It yields so many interesting technical computer science and computer engineering and networking challenges to go make this a reality. That it's one of the great differentiators of Google as a company that we get to go work on so many interesting problems. Now, of course, besides this, it isn't always said, but you should know, underneath this is, of course, commerce. Google is a major facilitator of commerce in so doing, and that's a profitable venture which pays for this. It's the bulk of how Google makes its money. So there are hundreds of thousands of people that put up, or companies and people that put up AdWords alongside of Google search results. There are hundreds of thousands of publishers that utilize our technique for placing ads on their pages. And we have really an enormous amount of additional things going on with advertising that are mentioned on that. And indeed, on YouTube, independent content creators are now the fastest growing segment of all our partners, with millions of videos each day earning revenue for partners in the program. So there's a commerce side of this that pays for this organizing information, and that's not an insignificant part of where Google tries to innovate as well. Just as an example, we are, as you know, very proud to have Hal Varian at Google, who's been very involved in economics and computer science and the merger of those things together, which has happened at our company. So where does innovation begin at Google? Well, I think it begins first and foremost with a commitment to advancing technology. So it's probably not surprising that we have that, given that our founders were PhD students in computer science, our chairman is a computer scientist. But it's throughout the whole organization, we're not trying to do easy things, we're trying to advance technology, and it's our view that if we don't do that, we will become stale and unsuccessful. And that's a culture throughout the business. Those of you that are students might say, well, that's of course obvious. Every business must be like that. But I assure you it's not actually true. A lot of businesses say, what we do is this, we're very good at it, we want to stay inside of what we're really good at, and we want to do the easy thing. Advancing technology may not be the easy thing. We want to do the advancing technology, even if it is not always easy. As I said, we have a rich domain to work in due to our mission. So there are issues of information retrieval, there are human factors, security, machine performance, you name it, right? In order to do our mission, there's a tremendous opportunity to work on interesting problems. In fact, grand challenge problems. So if you think of what the grand challenge problems were traditionally in computer science, for example, machine translation. Machine translation is extremely interesting to Google because we would like to find things in any language, regardless of what language you speak or understand yourself. So machine translation, a grand challenge in this field that folks have talked about for 50 plus years, is a problem that probably in terms of practical impact we have made more progress on than anyone previously, just because it's so central to what we do. Another aspect of innovation that I think is important, and it's very important to many of you here as you think about engineering and research and academia and industry, et cetera, is that in our view, in computer science and related technologies, making things actually work, challenging things work, may be every bit as intellectually stimulating and challenging as coming up with the initial concept. So we're not trying to disparage research, far be it for the VP of research to say, don't come up with new ideas. But on the other hand, we also believe across the company that making things a reality in these complex systems is equally challenging. So we have a cultural agreement across our business that all of these activities can be really challenging to do well. And for example, because of that, in our engineering team, we have approximately a third of our team as PhDs, approximately a third masters, and approximately a third bachelors. And that shows that we get some of the smartest and most well-trained individuals, perhaps that had even thought they would do a purely research career, actually making systems at scale solving these grand challenge problems really work. Now, indeed, as I alluded to earlier, and was alluded to by Dean Shastri in his introduction to this, we get a lot of leverage from the technologies and approach that we take. And let me go through those for a moment. So first, as has been reported, and the computer scientists amongst you know this, we have a common distributed system, a collection of computers and networks and storage devices and the like that underlies what we do. It's called a cloud computing system today. I don't think it was called that when we started, but that's what it's now called. So there's vast amounts of data, 10 to the 18th order bytes. I don't know exactly how many, but it's one with a lot of zeros, bytes of data out there. There's processing in the cloud, right? Hundreds of thousands of CPUs that are out there responding to queries and performing services. And there's global usage. So the interesting thing about a cloud is not just that there's all this computation in it, but all the usage terminates at one point in the cloud. And we'll get back to the implications of that in a moment on that usage side. But that's a key part of it. It's not just the computation is more manageable. It's not just that the processing is more manageable, but the usage terminates there. So it's possible for the cloud to know a lot about the interactions of individuals. So the implications of this are economies of scale from shared infrastructure. This had been talked about for many years. Lots of companies, IBM when I was there, talked about utility computing. So it's been understood for a long time this is going to happen. The economics, the availability of high-performance networking led to this really happening in spades this decade. Low barriers to product launch. One of the nice things about putting services in the cloud is that you don't have to physically ship them. You don't have to test them on an endless variety of different operating systems and computers. If you want to change them, it's easier to do. If you make a mistake, you can fix it more easily. So there are advantages in terms of reduced barriers to entry internally to shipping things. And frankly, it's possible for us to use our own cloud to decentralize our development. So Google has created a large number of laboratories around the world where we can hire really talented people without forcing everyone to move to Mountain View. As beautiful as the Bay Area is, amazingly enough, not absolutely everyone wants to move to Mountain View. Second, we do focus on services. So we primarily deliver services to achieve our mission. And some of these I already mentioned relating to the cloud, the lower cost of development, economies of scale. Location transparency is one I want to mention. I'll mention that next. So no matter where you are, you can access the service. You don't have to have a particular device, a particular computer, a particular disk drive. Resilience is also very likely to be enhanced because we can replicate processing and storage effectively across multiple locales so that the system just continues to work despite a very large number of failures in environments. We can mask those through replication. We can make it easier to integrate services to provide coherent, say, email, calendaring integration or search and integration with other activities. And then finally, one of these things, and now I'm going to begin to get to this aggregated user feedback, because the services terminate, because all these interactions terminate in services that are common, we can aggregate user feedback. So we can learn what users want, what they like, what they don't like, and in fact, build systems that learn from the usage of the users. So it leads to a variety of services. There's really, we don't know what the limit will be. You probably can't read all these things. You're not intended to be able to in various rows, but there's a lot of stuff, and there's even more than this in doing it. The third point I want to make is because of this notion of a system working with users, a key aspect that we leverage is a kind of holistic approach to design. So it's possible to think a computer scientist should focus extraordinarily on the computer system or computer service, and the user is sort of an addendum. Yes, there may be work in HCI and human-computer interaction or user experience, but basically, we are the high priests of machines. And we focus on the development of programming interface and user interfaces on machines. And yeah, they're used by people, and occasionally we have to go out and survey and find out what people think and try to make them work right. I would say our field was more like that than not for most of the field's existence. And there were many good reasons why that was true, and it's changed somewhat today. Today, what we really can do and what we must do and what we do to a very large extent is really recognize what's going on in these cloud-based services is a system is working which is, of course, significantly computational, but it is to a large degree based on learning from the interactions of all the users. So the users are an equal party to the operation of the system. So many of you have seen the benefits of Google spelling correction. That's based upon users making mistakes and correcting them is how we do it. So we learn when users misspell something, they get no results. They scratch their head, they think of something else and they try it. They get results and they like some of them and they click on them. And we can equate, because of the juxtaposition in log entries, the misspelled terms with the correctly spelled terms and do correction. It's a very simple idea. It's incredibly powerful. And I would bet if you poll people, it's one of the most valuable things people find in a search engine is you don't have to exactly have to type it exactly right. We'll get it most of the time anyway. So it's, I remember as a kid trying to find words in a dictionary. I never understood why dictionaries quite work, because you had to spell the word before you could look it up. And that's what you didn't know, was how to spell the word. Well, we fixed that problem. So that's this, and there's a virtuous circle that occurs. So I think this is a fundamental change in computer science. And it's an opportunity, whenever there's a fundamental change, to generate a lot of innovation. And Google has been very fortunate to be at the forefront of that. One of the things around that is, with all of this usage, there's just a tremendous opportunity to measure. So you can measure the benefits of things in these services. You can see, if we do this, what is the result? How many people click on things? How does usage of the system grow? There's just an enormous amount of feedback we can get through instrumenting the usage, measuring usage, or measuring the operation of the system. So Google is one of the most empirical companies that I could imagine having. It's quite interesting. If I think back to my career in computer science, there was realistically probably the likelihood, the bulk of the field was almost mathematical. We felt we should be able to analyze everything from first principles, because computers were, after all, mathematical in nature, right? This was a man-invented system. So it's a mathematical concept. And if you read the work of Dijkstra and such, you see that attitude towards computer science. Today, this innovation comes about from an empirical structure which I don't think we would have contemplated 30 years ago, and I certainly didn't. The ability to learn from mass usage was not something part of the curriculum in computer science at Stanford when I was there, nor was it when you were here, right, Dean? So those are some of the things we leverage. Now, how do we add to that the cultural elements? It would be nice to say, perhaps to take an engineering view, but if you just put a few key things in place, everything else happens. It's not true. There are cultural aspects to every institution that have to be tended to. So first, talent. So Google, from day one, has been extremely focused on aggregating top talent. So indeed, if you want to go to Google or work with Google at some point, be talented. Strive to do your very best. That's very important to this. As I've mentioned already, we don't believe that talent can just be applied to the research sides of what we do. It's required even to make everything work on a regular basis. The problems are sufficiently challenging. Now, how do you get talent in an organization? Well, you have to have the will to do it. So you have to really be focused on it. So the organization has to agree. I have seen organizations which have said, we can't retain talented people, so it's not worth going after them. We are not that way. We are determined to retain talented people, and we have the will to do it. I think talent seeks out other talent. So once you start, just like at Berkeley, the reason many of you are here is because there's so many other smart people around you. That's true at Google as well. The opportunity to have impact is something which attracts talent, and we are dedicated to having impact. We've clearly tried to build a culture that's fun for people to work in. And then, of course, all the traditional benefits like paychecks and such things are not insignificant as well. And we benefit from our mutual talent, our comparative advantages of scale and broad use, and from this architecture. Now, indeed, for research and technology types, the fact that we have this broad distributed system with the ability to project services means we can work in vivo. So researchers at Google, advanced technologists, can build things which we try out very easily. and this is a real advantage of the Google innovation culture, we can say to someone, well, all right, that's a very interesting idea. That might really work. Let's try it out. And we can take 1% of our servers providing a service and try it out on 1% of our servers and measure the result. And if it's positive, we've got a hit. And if it's negative, well, we impacted some of our users a little bit. Hopefully not. If it was a serious impact, we would certainly try not to do it. But we do some experimentation quickly, and we get statistically significant results and then move forward. So we can apply hill climbing algorithms very effectively to innovation. Now, another thing we've tried to do, and I'll try to say this precisely because it's a little bit of a challenging thing to get right. We've tried to decentralize to the maximum extent we can. Now, I'm not a believer in anarchy. I'm not a believer, I mean, I'm almost a professional manager at this point in my career, so I can't argue that managers have no value, right? That would be self-destructive, I think. But we really want, to the maximal extent that we can, to decentralize. And we'd rather make mistakes from having teams that, are working more independently than they should to having teams that are over-managed. So we'll err on the side of empowerment and decentralization. Now, we felt it's somewhat easier to do at our organization for a few reasons. One is we have this services architecture where relatively small teams can build services, and if they provide common programming interfaces, they can communicate with each other using remote procedure call-like connection mechanisms. So rather than big monolithic systems, we've built things more modularly. Now, we'll see how well we do long term if that hangs together, but for the moment that's remained reasonably true. Second, we have a lot of talent, which means, frankly, people need less direction. So that's another reason we can do it. The 20% time story you've heard about is another strong statement. Now, it has pluses and minuses. It doesn't always work the way we want. People are too busy to use it. But merely the statement that we make, our goal to try to give people the knowledge that we trust you, we think you can find good things to go do, is an important statement. And just as advice, if you ever become managers, it's very easy to say no. The easiest thing is to say no. Oh, I can't do that, my budget. We have to try very hard to say yes. And then last but not least, we try to use technology internally to help. So I was at your sister institution at UCSD yesterday giving a talk, a little different than this one actually. And the question came up, how do people know what each other are doing? How do you manage that? And I would say we try very hard to use all of the Web 2.0 technologies and video conferencing more than anybody else to try to keep people in touch with each other. I mean, one approach is to create big hierarchies and have reports and reviews and get information up and then filter it down. The other is to try to use more of these decentralized communication technologies, wikis and email and blogs and things like that. And we really do practice that with an immense amount of open sharing in the business. So we do use technology to reduce hierarchy wherever we can. We do use management by objectives. We're strongly focused on getting things done, so we set quarterly objectives in Google and try to measure ourselves against them. It doesn't mean you can't have long-term efforts, but we're human beings. We have finite lifespans. It's nice to show progress at some level. We do peer review at many levels, just as universities do, and we publish snippets on what we do every week. So I, for example, publish what I did last week, 5 lines. So if my boss or Jeff Walsh in University Relations wants to see it works for me, wants to see what I did last week, he can go check. And every week it's there. Maybe graduate students should do that so their advisors know what they're doing. I'm not sure I would have liked that as a graduate student, but perhaps. And as I mentioned, we do a lot of other things in information dissemination. Another thing we try to do to be innovative is we recognize that complacency is a great risk. It's extremely easy to feel complacent if you're doing well and an industry leader, and we try very hard not to do that. So we, for example, in our 10th anniversary, which happened just a few months ago, we published on the Google official blog, our view of where technology was going, and we had many folks write about that. I and Franz Och, who's a translation guy working for us, wrote about this. Marissa Meyer wrote about search. You could type that, and you'll see we're really thinking pretty aggressively about where all this is going to go in the future, partially just to motivate ourselves to just keep going. You need to also use external metrics. You have to hold yourself up. So we have to publish. In fact, Google's trying to publish more. Some of you may wonder, have we published enough? Well, we were a startup for many years. We were rather busy. We are trying to publish more now. We have no desire at Google for people to come work for us and then to get swallowed up and never heard from again. So we'll do what we can to try to encourage as much publication as we can. And finally, research. So research has been part of Google since the very early days, not as formal as at some institutions, but there were researchers hired at Google in the first, 10 or 20 or 30 employees at Google. So our mission is relatively, I would say, normal for a research mission. Our goal is to innovate and to catalyze innovation with others and to learn, because needless to say, Google doesn't do everything itself, in ways that help us achieve our mission. We're blessed with the ability to operate in most areas of computer science because they're relevant to the Google mission, as I said. We have a diversified portfolio, I believe, although we're always trying to tune that and make sure it's diversified enough in both space across different dimensions and in time. And we very much desire a strong relationship to the academic community, and we are increasingly emphasizing publication as we should. We've had big impact with this research mission. I'm trying to transition now a little bit more towards the research side of things in this part of the presentation. So these particular papers that have been published, I believe, are at least among the most influential papers written in the last decade to define cluster computing. So Google really was able to run with perhaps old ideas they've been called multi-computers if you look far enough back. It's an old term. But network-based processing, we ran with that very effectively. The firm did a very good job with that in terms of shared file systems and infrastructure to manage systems and programming models to do batch processing on large numbers of systems simultaneously and to store data in a record-oriented way as well. I would say to a large extent these have defined a lot of systems work in computer systems at the present time and how we expect to use parallelism going forward, given that raw advances in density and frequency are getting harder to come by on individual chips. Just an example of some work by Luis Barroso on disk drive failures. Just a nice snippet of how we do things at Google, what we can do. We have a lot of disk drives, as you would imagine. Anyone that uses Gmail would understand that very well. There's been a lot of valuable work. I remember Professor Dan Sawarek at CMU was looking at empirical analysis of disk drives when I was a professor in the 1980s. But we have access to so many disk drives with full knowledge of the load those disk drives are under. We thought we could do a better job of characterizing failures in disk drives. So, and in science, you often think you know the answer and you don't. So, most people would think, for example, the second bullet, that as temperatures rise, disk drive failures will increase. Right? We all know it's better to keep machinery cooler, right? It's got to be true. Well, we built a collection architecture, and this shows, servers and collectors and going into storage systems, big table, and then going through, sort of batch processing analytical programs. That enables us to get this kind of data, which is easily shown. So you see in the bar chart a quasi-normal distribution of the temperatures at which disk drives are operating at Google, at least when this paper was done. And then you see the failure rate that exists as a function of temperature. And the failure rate goes down through much of the spectrum. Now, I frankly think we should all be skeptical. We should say, well, maybe the machine rooms that were running really cold had a lot of dust in them, right? Possible there are other effects. Correlation does not imply cause and effect. But I think there are at least powerful hypotheses that are generated by this kind of empirical work as to how to maximize the lifespan of disk drives, something that's valuable to us and to the world. And by the way, there are real energy implications to this. It's a lot cheaper to run a machine room at higher temperatures than it is to run at lower temperatures. So there are real benefits to this kind of work. So this is an example of some empirical systems work at Google that we've done. I could spend more time talking about innovations in browsers, but clearly Google would like very secure access to services from browsers, and we've been working in open source to do that. Same thing's true in mobile operating systems, so we've catalyzed, we think, a lot of innovation in open source operating systems around Android, particularly focused on handheld devices like this here, Google Phone, and others that will be coming out. Voice recognition is an area that we think is extremely important, particularly as people want to use mobile devices, and everyone finds it hard to type on mobile devices, particularly, say, when driving. So we launched about a year and a half ago a free business finder, 1-800-GOOG-411. Has anyone used it here? How does it work? Pretty good? Yeah, it actually really works. I think so, too. Anyone think bad? Okay, one. All right. Can we talk later? I want to hear why. It's not that I want to intimidate you into not saying yes. I'd like to just know what problem you had with it. Anyway, we learned a lot from this. And we've now been able to take that technology the next step, which is where we really wanted to go all along, was voice search. So now we have voice search on the Apple iPhone. You'll see it in other platforms in the future and other languages. Wouldn't it really be nice if, like one would expect in Star Trek, you really can say, I live in Manhattan, next train schedule, Grand Central Station, Pelham Manor, which is something I need to do regularly at weird hours to go home to find out, because I can never seem to remember when the trains run. So this is really going to be a valuable addition, I think, to making information accessible and a core part of our mission. And there are fascinating questions in all of this. I could talk a lot about speech recognition technologies. Perhaps I will. We think we'll be able to learn from correct recognitions how to make the system automatically improve its quality. So the more use, the better the quality automatically in an unsupervised way. So I'm looking at Brian Harvey as I discuss this, because he and I were having a discussion last week where he was confronting me over privacy issues associated with this. So part of what I'm doing, Brian, is telling you all the reasons why this is an incredibly good idea. And you're, of course, welcome to ask a question, not that you would ever censor yourself anyway here. I knew Brian when I was a high school student, and Brian was nice enough to teach me to be an engineer at MIT's radio station, for which I am deeply grateful, truly. I think Brian probably has taught many of you computer science, so he really had a formative impact on my career as well. And now I'll ask an even harder question because of that. So that's one thing, but user experience is a big one. So as we look at the user experience of these multimodal technologies, how do we get the interface design exactly correct in this? It's a really interesting question. For example, so when you do a search, should we show you the transcription so that if we don't get it exactly right, you could select among multiple transcriptions of what we said, so that you could select, say, the third transcription, which is closer to what you said than the first transcription. We do that with search. Maybe we should do it as an intermediate result. And in fact, we do this on the iPhone. We're not certain if this is exactly the right thing to do or not. It's going to require more study. So they're fascinating issues. In web translation, as I mentioned, that's been a really important problem. I'm very proud to say the team at Google has now handling about 40 squared language pairs. So we can translate from 40 languages into 40 other languages. People rarely translate from one language into itself, but don't laugh about that. That itself is a very interesting technical idea. If round-trip translation could be a source of semantic information that's significant. So it's a fairly easy way, if you take some utterance and translate it back to itself, you may get a bunch of synonyms that you can then figure out, and it may be a very good synonym finder. And there are other ideas as well. So this has been a successful thing. There's a lot more to do. So there's no end to the excitement and innovation in this. How do we do languages where there isn't good training data? So we were talking yesterday to a professor at UCSD who's looking for the tomb of Genghis Khan. And that's a really exciting mission, trying to use a lot of image analysis and mapping and Google Earth-like technology and things like that in order to do this. it came up that they really need Mongolian translation. There's probably not a very big corpus of Mongolian English and English Mongolian to train our speech translation system. So how are we going to do the small languages? That's going to be an interesting challenge for us, given these statistical approaches. How do we incorporate syntax, which probably has a role in improving quality, but we have to do syntactic parsing extremely fast, given the enormous size of the corpora that we have. And we've made innovations in that. We also then need parsers in every language, which is not so easy to do. So there are great issues and challenges and that excite us in innovation in this activity. One of the things I found, for example, is that many people use the translation capabilities of Google, but actually not many people are doing multilingual search. How many people in the room have done multilingual search at Google? How many people have used Google Translate? It's a completely consistent result. So the interesting results, isn't this interesting? Maybe you don't find it such, that many people have used the raw translation capabilities of Google. But very few people do, find me information on this independent of language or in this language. So it's very interesting that that's true. And this was true, asked the same question at 2 universities in China with exactly the same ratio of hands. Very interesting. So I don't know if we have the right user interface or what, or maybe multilingual search. Maybe people aren't so interested in what other languages say about some subject. So we could talk more about machine translation. Image analysis, image search, as many of you know at Berkeley, where you're doing lots of pioneering work in this, is a fast growing part of search on the web. So how do we do all of the challenging things that people want in image search, which involve navigation, find images like other images, and finding the best image, really trying to get the most up-to-date image and the like. And we do more than just image search with all the mapping and geographic activities like this street view image here of the Marina District. It's just a tremendous amount of image processing that's going to go on, and way more so. And the volumes are going to be great as you move to higher and higher definition, particularly in video. So there's a lot of problems. These are classic problems in the field, and they're absolutely central to what we're doing. We're interested in image information extraction. So with all the information that we have, might we find a way to represent all entities in the world and every possible relationship between those entities and label the relationships in some useful way? And could we, in fact, make that a service that we use ourselves or perhaps for the world at large? Is this a way of generating this kind of automatic ontology of information from the vast gulf of things we have? This is a long-term effort, but it's one that could bear a lot of fruit. On a nearer-term thing, one of the special initiatives I'm involved in is Google Health. If our mission is to organize the world's information and make it universally accessible and useful, it's hard to not conclude that health information is among the least organized and least useful and with the most potential of any information. So there are fascinating challenges on data quality, on usability, on the engineering of all of the integration, indeed on security and privacy, public policy, but we're right in the middle of that activity at this point. And many classic things in computer science are all relevant to innovation, and we are fascinated and working on many of these. Eric Schmidt, who's our chairman, of course a distinguished alum of the PhD program here, when he was asked at a computer science and telecommunications board meeting what his favorite challenge was, this was just 2 weeks ago, he said, gee, programming is still a bear. After all this time, and particularly with the advent of parallel processing, it's extremely difficult to utilize the inherent parallelism that systems have today, let alone the parallelism that will be there in the future. So that's just a classic programming problem that remains, continually changes as computation models change and applications change, but there's still work to be done even in the core of our field. As it relates to universities, as I started, we really desire a strong relation with academe. We generally prefer bottom-up approach, excuse me. That's a better way of saying it. I always get that wrong. What we really have to offer is a knowledge of challenging problems. We see really good problems. We have a skilled employee base, and we have opportunities for internship, sabbatical, and occasionally through grants or things like that, money. Although I actually think the other things are more important. The university, you folks have immense talent and breadth and depth of perspective, and also you don't know when things can't be done. Right? We sometimes beat our heads against the wall and conclude they're not solvable. You continually have new students and hence have idealism, which is extremely important. So we have a lot of internships. I'll discuss that. It's a very vibrant internship program this year. So despite what you may have seen about employment issues in the industry, Google will have lots of interns this summer. We have visiting faculty members that are at Google, about 20 at any given time. And we provide about 100 research grants or more that we've given out over time as well. With respect to Berkeley, I think there are about 30 students a year, mostly PhDs that have been interns at Google. We've had lots of hires. I think what I heard is there are more than 800 UCSD alums at Google. So thank you. We are, to a large extent, Berkeley, I guess, at Google. The intern program is underway. And there are many faculty members that have gotten grants. Some of them are in the room, and you see some of these. We've done a particularly large amount of funding and work with the RAD Lab, led by Patterson, Katz, Jordan, and Shankar. And Ion, how do you pronounce Stoica? Stoica. And in fact, I'm spending 4 hours starting at 1 o'clock over there today, reviewing what's gone on, and we hope to learn a lot from the techniques and systems management and other research being done there. We fund other things. We've been pleased to fund the NSF program on providing data-intensive computation for use. We've provided hardware and telecommunications access for a few thousand machines as part of the CLUI program to provide access to MapReduce technology, and we're involved with that. And you can find out a lot about what we're doing on growing sites at Google. So check out research.google.com and look around. We've been beginning to produce videos for YouTube on some of our technologies to make things more broadly available. So with that, I don't think I'll take time to summarize. Instead, because I think we have a pretty hard stop, I'll see if there are any questions I can answer on any subject. Thank you.
Since we are broadcasting this and recording this, please, those of you that have questions, if you can step up to one of the two microphones. If no one else volunteers, oh, good. I was going to call on Brian Harvey.
No, can't do that. Then it'll really kill me.
Hi, thanks. Great talk. So you mentioned the importance of the empirical nature of research. And as you would expect, it becomes extremely hard to get the amount of data that Google has to do research. So what's the role of research done elsewhere in schools and stuff? And how does that combine with the approach of needing so much data to advance?
Yeah, so the question is a very good question. In fact, empirically, I think it's the number one most asked question that I get, that you just asked, self-referentially here. So it's a very good question. So in terms of the raw data, there is more data on the web than people ever had previously. So in terms of just the raw information to begin with, there are tremendous amounts. It's user interaction that's the issue, right? So that's where the problem is. CMU is doing a crawl on the CLUI cluster, so they'll get a reasonably good crawl. Will it be as good as our crawl or Yahoo's crawl, or probably not, but it doesn't have to be. There's tons of data they'll get. But the interaction is indeed a challenge. So the issue is, and in fact, it is hard for the organizations that get the data to release it. So it is truly, as much as we would like to release data, and honestly, we couldn't, it's not for competitive reasons. It's really privacy issues that make it extremely difficult to release information. And even if it weren't privacy, it would be the perception of privacy issues, which are just as bad for a company with a valuable brand. So it's hard for us to solve it. I think creative approaches are what are needed. So for example, what I wonder about, and I had this idea just yesterday, I hadn't actually thought about it, is to what extent could university researchers provide intermediaries, which are used on campus or with other research communities or whatever, which would watch what's going on with targeted populations, not duplicate the service that we or our competition provides, but watch what happens and then keep a record of it, and it would be your data then. And we wouldn't object to that, right? How could we object? You'd be interposing intermediaries. I'm sort of the view there are going to be solutions to it. They're going to be you have to be very creative. You'll have to find domains where data is available of this form, find ways of getting it, and develop environments where you can do it. It is a challenge, though. So it's a very good question. It's not surprising. It's the first question here. All right, another question.
Yeah,
Hi.
Can you hear me?
Yes.
Okay. With the growing amount of biological information, I'm a biologist, and pretty soon we're going to be able to sequence an entire genome within 24 hours. I'm just wondering, it seems like Google is uniquely positioned to do the appropriate data mining. Are you interested at Google at all in doing bioinformatics and pursuing sort of that line of work?
So, yes. I mean, first, we are cognizant of the fact that in comparison to the biomedical field, it's a huge research apparatus in America and the world. So we're pretty small in comparison. So we have to figure out in a targeted way where we can be valuable. All right. So we're not a biological research company, right? We're a different kind of business. So we have to be careful to do something where we can really make a contribution. So that's number one. Number two, we do believe, and one of the reasons behind Google Health is that individuals will need to store their genomic or proteomic or other data over time in order to get the right medications, for example. And then there'll be therapeutic reasons for that, which we see as extremely important. And then as you bring up, there are data mining opportunities that are just amazing to go look through this. In the fullness of time, if we can figure out a way to make Google Health continue to grow and be useful, we'll start thinking about how we could do privacy-preserving kinds of operations on the data that would enable us to really provide value to the research community. So we're very interested. We're not exactly sure what to do. It's not the right time for Google Health yet. But you're right, the vast computation and storage is clearly something we have to keep our eyes on.
Brian really has a question.
Okay,
Yes, sir. Hi, Brian.
Since you insist, hi. Google Health
Yeah,
and privacy.
yeah.
Google has promised that it's not going to do with the information stored in Google Health what it does with everything else, namely sell people to advertisers.
Right.
And if not, how are you going to make any money on Google Health?
Okay, so first, I don't want to accept the premise that we're selling everybody's data to advertisers, but aside from that point, so the question is, what's the business? So the question is, what's the business model behind Google Health? So the answer is, I think people like Google and use Google because they realize we're sort of a partner with them in trying to make information useful. So I think people have a generally good view of our company and saying, yeah, they're really trying to organize books and, search email and structure calendars and all these things. And it's a good thing and it's a useful service. And, they're making money, but we're getting a lot of value as consumers. So it's a good thing. So what we believe with Google Health is that almost everyone realizes that the medical data is so disaggregated that it's also a good thing if we could bring that together. So we think it will engender more usage of Google, and that more usage of Google will correspond to more searches, and that's really the bulk of the business today. So that's the business model, and that would seem to be sufficient to fund this.
So it's a loss leader.
I think that, I don't know that you can say that. I think you have to look at the Google business in a fairly holistic sense, right? There are many things that are part of what we do. And there's a reason. I mean, every Google talk, if you've heard other talks, I bet the mission statement shows up first in almost every talk from Google. And the reason is it is really what the value proposition we have is for society, is that our job is, our primary job is not to be a computational engine. Our job is not to be a text editor. Our job is to organize the world's information. So that's what this is about. But it's a great question. Other things?
Michael, you have further questions, so I'm sorry to put you on the spot, but you, he had a question before you came.
I see. All right.
At one of your slides, it was an issue of experiments and science and engineering. We in engineering, of course, in a different business. To us, data means something else, not just, find me some information and so on. We want to combine specific data and put it to specific application, let's say codes that run it and so on. Is that something also of interest to you guys, or it's a completely different domain that only we stuck with?
So I'm not sure. I must tell you, I would love to answer the question, but I didn't fully understand it. So I need an interpreter, or you need to reinterpret the question.
If I want to look for, let's say, heat of formation of methane, I don't know if you understand what I'm saying. But
I know what methane is, but I don't know beyond that.
Some properties, say molecular weight.
Okay.
I cannot go by 99 probabilities that it's the right number. I have to go by 100. So I cannot make it like a rank search, which is a great thing. We love it, right? But in science, we need to be absolutely sure that the number we found is exact numbers that we want. Mm-hmm. Is that something of your interest, or it's outside? And that
I see. So I think this is a very deep question. So and I think it's. So I don't know. I don't think that's a sufficient answer. However, I would like to hope that's the answer, but that's a meta answer. So I don't think that'll work. So this is really. So one of the things that happened with search, right, was it kind of revolutionized information processing, which was almost entirely focused on get the exact data. There had been an IR community for a long time, but it was a sideline to the main database community. With due respect to all the IR people that might be in the room. The main thing going on was relational databases, Stonebreaker here and Larry Rowe and others that were here and elsewhere. Get me the exact result, right? Tell me the exact, average raise that was given to employees in 2004 that had a position of level 7 and below level 9 in this department, right? You got exact data. So Google and others and IR found that this probabilistic set of results was really the focus on it was too little, and that in fact it was really great. And in fact these problems that almost seemed impossible to solve would be solvable probabilistically pretty well. So you give people 10 results on the page, you'll probably get the right one or one good enough. And it frustrated the database community, the traditional community, but worked really well. So there's a role for both is what I'm trying to get at. And we are interested in it. So look, as computer scientists or engineers, I'm not sure exactly what we are. We're in engineering schools, we're in information sciences schools, we're in science, humanities and science programs. I'm not sure what we are. Some of what we do is incredibly precise. So at Google, as empirical as we may be, we hire many of the best algorithmaticians that prove properties of their algorithms to make sure they are exactly right. All right, so we care about precision in what we do, and we care and we recognize if we're going to return a healthcare record, while I suppose we can't be sure the test result that came from the testing agency is right, we better not mess it up further when we return the result, right? We better return exactly what we get. So there are times when we are exactly interested in precision, and there are times when, hey, we translated this, it's a pretty good translation, it's worth it. So I think we have to do both. And I think both things are relevant to Google. And I think you could even look at, would you ever imagine, I mean, it's a very interesting question. Would you ever imagine a kind of mode in a search engine where you're guaranteed something, you get some guarantees? The problem then is what constitutes truth? And an interesting question of who is the arbiter of truth? And it doesn't seem necessarily likely that it's a very easy question to answer, or that in fact any company becomes the arbiter of truth.
Okay,
Yep.
final question. Yasmin.
Final question.
Oh, you want one more?
This was easy question, a difficult question for you. Relationship between privacy and data mining that government wants to do. What is your position? What is your obligation toward the government?
Well, I think we abide by the laws of the land. I mean, we would like to keep everything, you know, we have privacy policies that we intend to maintain, but clearly we abide by the laws of the land in which we operate.
Meaning my Gmail goes through government computers?
I have no reason to think that's true. In fact, I rather doubt that's true. On the other hand, if a court issues a subpoena, we abide by the laws of the land.
Okay, you have the last question.
Oh boy, so much pressure. Just to satisfy my curiosity, did you make your presentation in Google Docs?
Did I make my presentation in Google Docs? No, I did not. But however, I sometimes used, I didn't initially write it in Google Docs, and the reason is that I often have disconnected use on airplanes, and that's the reason. But Google Docs is getting disconnected operations, so there'll be no excuse very shortly.
Oh, good to hear.
Well, join me once more.
All right, thanks very much.
Okay, those of you that have waited politely all this time, we've got lunch outside, so please partake of it, and welcome back on March 6th. Avide. Michael, there's some faculty who wanted to. This is Michael.